Hello and welcome. In this video, we'll show you how simple geometries look like in orthographic projection, mainly flat surfaces and circular features. Then we'll go on talk about how you can draw circles without using a compass. And then we'll finally wrap up with how many views do you need to represent objects. The first thing we're going to start with is using or representing flat surfaces. Now, let's use this example. This shape shown in the isometric view, and it has three types of flat surfaces. The first type, which is labeled A, is an orthogonal surface, and it's called orthogonal because that surface, flat surface, either it's parallel and perpendicular to the projection planes. And this means that in one of the views it will not be distorted, it will look as it is. And in the two other views, it will be represented by a straight line. Let's look at this surface here that I've colored in the green. On the top view, you can see that it's outlined by this, and it looks exactly how it's supposed to look from the top without any distortion. Now, if you look at the front view, that flat surface is now just represented by that line, and you can use projection line to show you that it does reach those extremes. Similarly, it's in the right side view, it's all of that straight line. So that's an orthogonal surface. The second type of surface is an inclined surface, which is a flat surface that is obviously inclining in only one dimensions. And here it's surface B, the orange one. With inclined surfaces, they appear distorted in two views, and they appear to length and undistorted but as a line in the third view. So surface B from the top view will look foreshortened. That's what I mean by distorted. It will be foreshortened because of the projection. And what do I mean by that? Well, if you look at, if that's the horizontal projection plane, and again with third angle projection, the observer is here, and the object will look something like that. So that's, we're looking from the front, but the observer is looking from the top. And if we project that, you can see it's that length. But if you project it, it's going to be shorter. And how much gets shorter depends on the incline of the object. In the second view, the right side view in this case, it will also appear as a rectangle and it will be shortened. The only view which it will appear undistorted, it will be in this view where it appears as this line to length. The final surface is an oblique surface, which is a surface that is inclined in two dimensions, which means it's going to be foreshortened in all three projection views. It's not parallel to any of those principal projection planes, and therefore it's going to be distorted or foreshortened in all three views. In this case, it's going to be surface C, and in this case it's going to appear as a triangle in all three views, and all the lengths and these views will be, some of them will be foreshortened. Let's move on to circular features. With circular features, they're going to be quite complicated if the circular feature is not parallel or perpendicular to one of the projection planes. So we'll just stick with the main circular feature to be parallel or perpendicular to the projection planes, just like the example shown here. So this shape, well, it looks like a toilet seat with the hole in the wrong place, but let's move on beyond that. These are the orthographic views associated with that object, and it has a circular hole right here. And in the front view, you can see that that circle appears perfectly in the front view. And when you project that circular feature to the right or the top view, it becomes as a rectangular outline. And this is expected. So if you look at the cylinder, then from the front, you'll have the circle, and on the side, you'll see the rectangle. To avoid confusion, if you didn't have the front view, to avoid confusion, to tell you that, hey, this is a circular feature, not a rectangular block, That's why we need to add those center lines. So center lines with circular features are necessary. And with center lines, you have to indicate the center line if you can see it. So in this case, we have the center line here or the center line in the front view. And the center line should extend slightly beyond the circular feature, not the entire view. You can see on the right side view, this center line extends slightly beyond, but it doesn't extend to the entire view or the entire drawing. Now, there is one case where we should pay attention to that where a circle doesn't appear as a circle. And this is when a circle is intersecting an inclined plane. In this case, the circle will appear as an ellipse. What do I mean? So imagine the same shape, but instead of the right view being as it is drawn now, let's imagine the right view looking like something like this. And we still have those hidden lines from a circular feature. And again, we can have that center line. Now, because it's cut on an angle here, when viewed from the top, it will appear like an ellipse. I'd like you to use your projection line skills to figure that out for yourself. Now we will teach you how to draw circles without needing a compass. Well, you'd go, well, if I have a compass, why do I need to learn that? Well, yes, compass might be quicker to draw, but as I said, if you have a circular projection on an inclined plane, you will need to draw a circle, an ellipse. And the same technique that I'm going to teach you to draw circles, it can be applied to draw ellipses. So it might be a good idea to learn how to draw circles using this method, the box construction method. So let's take a look. The first thing you need to do is to draw the square in which the circle will fit inside. Next, put the midpoint indicators on each side of the square. Next thing you should do is draw the diagonals, and their intersection will indicate your center point of the circle. What you need to do is now is use your ruler and measure the length of your diagonal from the center point to the corner, and let's call that length D, whatever it is. Then from the same point, from the center of the circle, measure 70% of the diagonal and mark that with a point. You do that, you repeat that on all the remaining diagonals, and now you have 8 points that you can use to draw your circle. And remember, when you join these with a freeform arc, it should be tangent as it enters and leaves each of these points. So avoid sharp corners. So when you draw it, then you get a circle. The final thing is to actually delete these construction lines. You can leave the dots, but remove the diagonals in the square. And then you end up with almost perfect circle without needing to use a compass. Now the good news is this method can also be used to draw ellipses, as I mentioned earlier. And circular features or circles appear as ellipses in isometric views as well. So it's a good idea to learn how to use this box construction method. Finally, we'll talk about how many views do we need to fully represent a part or a shape. Now, the normal answer would be 3 views, so that to avoid any confusion. Now, with some parts, because they are simple, you may get away with 2 views, like this shape shown here. In this case, you probably don't need to draw the right side view because it's not going to add any new information. And there's no ambiguity in that because there's no other possible solution. Even simpler, some parts are very symmetric that only a single view is necessary. For example, we have this shape here. Now you'll probably notice that we do have a center line and go, oh yeah, we have a circular feature somewhat, but all these rectangular features could be rectangular blocks as well as cylinders. So how do we know which is which? Well, this is where we have that phi symbol. In engineering drawings, the phi symbol represents diameter, and it's usually followed by a number. So for example, phi 10 means it's a 10 millimeter diameter circular feature, hole or cylinder, whatever it is. And you'll notice in this view that all the features have a phi symbol next to them, which means they're all circular, and therefore we only need one view to represent this shape, because if you consider this as the front view, then the top view will be identical and the right side view will be a bunch of concentric circles. So coming back to the original point, in general you need 3 views to avoid any confusion. In some of the exercises you'll be doing in the tutorial, you'll be given 2 views to draw the third, and because there's not enough information given, there will be multiple possible solutions. And this is a great example where you definitely need 3 views rather than 2. And that will bring us to the end of this chapter. Thank you for watching.